So hello and very good morning dear students. We are meeting after a very long time. I hope you all are well at your home and your love towards mathematics has not faded away. Alright, so today's topic of discussion is continuity and differentiability because as we have completed the first four chapters, okay, that is relation and functions, inverse trigonometric functions, matrices and determinants. So this is our fifth chapter. So in this chapter we will be going to see what is the meaning of continuity, differentiability and the differentiation. Before starting this chapter, let me dive you some things which we have already discussed in 11th class. As I told you that calculus, which is the most important or the core part of mathematics, which includes two main things, that is differentiation and integration. And in the 11th class, we have seen about the limits and derivatives. There we have seen the limiting behavior of a function, as well as we have differentiated many functions like polynomial function, trigonometric functions and rest other logarithmic functions with the help of first principle of differentiation. I hope you are remembering the same. So keeping in mind all those things, we are with the new topic, that is continuity and differentiability. First, we are going to study about the continuous functions, that is the continuity of a function, and then differentiability, and we'll sum up these two and we'll head to the next topics. So as we are all set with the previous concepts of relation and function, so we have to keep in mind those also, because somewhere or the other we'll be taking the help of those two. Okay. So let's start with the first topic, that is continuity. Or we can say that when do we call a function to be a continuous function? Okay. Now why we are going to call all these things, we will see, and why we are trying to say that also we will see. Okay. So first of all, I'll draw some graphs over here so that to give you just a simple sense of what is the meaning of continuity. So continuity, you know, in like if we say generally, we know the meaning of continuity, that the thing which flows in a continuous manner or which has a streamlined flow, we can say. Okay. So that is what called the continuous or continuity. But in mathematics, how we will understand this? Let's understand with some graphs. Okay. So here drawn are the graphs which will depict you the meaning of continuous function. As you can see, the four graphs I have drawn. Now with this, let us clear the picture of continuous functions. Okay. So in this graph, if you can see the plotting, if you can start the plotting from this way or this way, that doesn't matter. The only thing is the curve here is a continuous one as compared to this one. If we say here the graph curve went up, then there is some break or a gap, then again it continued in this manner. If you see this graph, it is a straight line here which has some jump over here like this, and it again started. That means this value is going here and this value is going here with some jump. If you can see, this is again a continuous graph. So from these four graphs, what I mean to say that, as you can see, in this you have a break, in this you have a gap, but for these two you don't have any gap or break. So how can we understand that a continuous function is considered, or we can say the real valued function is said to be continuous if and only if the graph has no break or no gap, if and only if all the points are very much close enough so that we can draw a graph properly without lifting the pen from the plane of the paper. Are you getting? That means the points should be close enough so that we can draw a curve without lifting the pen from the plane of the paper. That means it should be on a single stroke. Are you getting this? So then only we can say that a function is said to be continuous function. So this is a continuous function, this is a continuous function, and if it is not continuous, then we call that as discontinuous. Okay, I hope somewhat you are getting the meaning of continuity and discontinuity. Now you may think that, can we remove this discontinuity? That means at which point we are getting the flaw. Okay, that means this is the area which is giving us problem, because at this point the function is not existing. That is why it is showing some gap or a break. So can we remove it? So definitely yes, we can remove such kind of thing, or like such kind of discontinuity. That is what it is called. If you can remove this discontinuity, then it is called the removable discontinuity. And if only when the fx exists, that means your function should exist at this point. Okay, so and if it does not exist, then we cannot, it is unremovable discontinuity. Okay, now we are going to just see one question here to understand, or okay, we'll take the question, but before that let's understand what are the conditions for the function to be continuous. Okay, so but before that, see, in 11th class we have seen about the limits. In limits we have seen that how do we prove that a function is continuous. So maybe we have done some questions there. We have found about LHL and RHL. Okay, that is left hand limit and its right hand limit. Okay, so we have done some questions in 11th class also, so we will be recalling them and we'll be using those concepts here also. Okay, so let me just write some definitions here. Okay, all right, so here I have written a very important definition. Let us read. A function fx is said to be continuous if and only if it is both left as well as right continuous at x is equal to c, that is limit x tends to c minus fx should be equal to limit x tends to c plus fx should be equal to fc. Now what is the meaning of this? This is LHL and this is RHL, and this is the value of the function at point x is equal to c. Okay, value at x is equal to c, value of function at x is equal to c. So what is the definition? What does the continuity says? That you can call a function or a real valued function to be continuous only when its LHL, left hand limit, right hand limit, and its value on the function, all these three should be equal. Okay, see, we know that a point x on a real axis can approach through two ways. How it can approach on a real axis? Either from the left side or either from the right hand side. So that is what we are going to use this concept, that if, say for example, if this is our function, then we are checking its left hand limits, its right hand limits, and on it the value on that particular function, are these three coming equal or not? If it is coming equal, then we say that it is continuous. Okay, so to check the continuity, we need to check its LHL, its RHL, and its value at that particular value of the function at that particular point, in which we have to prove that is it continuous or not. Okay, so I hope this definition is clear to you. Now my question to you is, when do you feel that your function won't be continuous? So here you have the things. Say for example, if the left hand side is not equal to right hand side, then it is discontinuous. If your right hand side is not equal to this value, or this value is not equal to this value. Okay, so these are some reasons which will just give you which will take you to the discontinuity. And as I said that this discontinuity can be removed or not removed, it depends on the function. Okay, so that also we have seen, the removable discontinuity and unremovable, or we can say non-renewable discontinuity. Okay, so from the book you can just have a check, there is a proper definition given. Okay, now let's start with some questions. In the questions we will understand more of the things which maybe we have skipped here. Okay, so we'll clear those things. Okay, so let's start. Okay, so let's start with the very first question of your exercise. See, let me tell you one thing. We are doing these questions. Please understand what is the algorithm, what is the thought process of how to start any of the question of such kind. Okay, in this exercise, in this continuity, we will be going to see 2 or 3 types of questions, just 2 or 3 types of questions, and what thought process we have to use in those questions I will explain you at each and every step. Okay, so now the question is, we have to examine whether this function is continuous or not at x is equal to 0. So at x is equal to 0, we have to just examine or test whether this function is continuous or not. Okay. So if you can see this question, you are given with fx is equal to x cube plus 3 when x is not equal to 0, and when x is equal to 0, your function value is giving 1. You know, we have the value, we always consider fx y is equal to fx. So at x is equal to 0, we are getting y is equal to 1. So can you see this 0, 1 coordinate if you plot in the graph? Okay, so that is how they are trying to say. Okay. Now, as I told you that we know that a particular x can be thought of on a, or particular function can be thought of on a real number or a real axis. In this real axis, we always, how can we check the continuity of this point or this function? By going on its left hand side and by going on its right hand side, and on itself what is the value. So we are going in left side, so we are actually going in negative. So if this is x is equal to 0, and if we are going in negative side, say for example if we are going some h, so here it will be 0 minus h. And if we are going at x is equal to 0, see this is at x is equal to 0, and we are going some in the right hand side, that means we are going in a positive side, we are going in some increasing order, increasing way, so it will be 0 plus h. Okay, so we are going to use this h method in this particular question. Okay, how? Let's start. See, I am going to prove, or we are going to, no, I'm not going to prove, we are going to see its left hand side and right hand side. First of all, we know at x is equal to 0, that means f0, we are getting 1 as the answer. Okay, I told you that at x is equal to c, we have to check the value fc. Okay, so at x is equal to 0, that means f0, that means here x is 0. So at f0, we are getting 1, so already it is given in the question. Okay, so keep it as it is. Now for LHL, for left hand limit, we know that limit x tends to c minus. Now in place of c we have 0, so we write limit x tends to 0 minus, and we are going to find fx. Now as I said that we will be going to use h method, so how for LHL it will be limit h tending to 0, we are taking a very negligible value of h which is tending to 0, which should not affect our value of the function. It should not affect the value of the function, or it should not disturb. That is why we are taking its limiting value. That is why it is tending to 0. Okay, f of 0 minus h. Okay, this 0, this one 0 I am writing. If it could be, if the question is of at x is equal to 1, so I would be writing 1 minus h. Okay, so for LHL it is 0 minus h. Okay, then we have fx as x cube plus 3. So can you tell me what will be f0 plus h? So at every value of x you have to put 0 minus h. Are you getting this? So what it will be, 0 minus h the whole cube plus 3. So this is nothing but minus h cube plus 3. Wait, I have not written limit. Limit h tends to 0, which is going on. Limit h tends to 0 minus h cube plus 3. Now apply the proper limits. What we will get? 0 plus 3, we will get 3. Okay, I hope this section is clear to you. Now for RHL, I hope you have started imagining what could be RHL. RHL, it will be 0 plus of fx. We are going in the right hand side. Okay, so limit h tends to 0, it will be f0 plus h. Limit h tends to 0, in place of this function we have to write 0 plus h. So 0 plus h the whole cube plus 3, which is nothing but h cube plus 3, and limit h tends to 0. On applying the proper limit, we will get 3 as the answer. Now our LHL is 3, which is equal to RHL, but it is not equal to the value of x at that particular function. So these two are equal, but it is not equal to this. So what we will write at last, that at point x is equal to 0, it is discontinuous. Okay, it is not continuous, or we can say it is discontinuous. I hope the things are clear to you. Now what is the removable discontinuity? How can you remove this discontinuity? So if I can add 2 here, if I am adding 2 here, it will become 3. So the value of, if x is equal to 0, I am getting 3 as the value. So f0 is equal to, I got 3. Now can you say this function is continuous? So definitely yes, because these 3 values are equal. Okay, so this is what we can remove the discontinuity by adding 2 here. So like this, the questions we have to see. Let's do the another question now. Now here you have the next question, which says if fx is given as x square minus 1 upon x minus 1 for x not equal to x not equal to 1, yeah, and fx is equal to 2 when x is equal to 1, then show that the function is continuous at x is equal to 1. Okay, this is the question which they have written in words. So it is nothing but fx is equal to, it is like this, x square minus 1 upon x minus 1 for x not equal to 1, and it is 2 when x is equal to 1, and we have to check its continuity, or we have to prove that yes, it is continuous at x is equal to 1. Now the very first thing which we will do, that our value of fx at x is equal to 1 is 2, so we have f2 is equal to 2, keep it aside. Okay, now come to the main thing, this function. See, this is x square minus 1 upon x minus 1. So here, if you put x is equal to 1 in this, we'll get 1 minus 1 upon 1 minus 1, which is 0 by 0. And 0 by 0 is considered to be indeterminate form or indeterminate value, because we cannot determine. So before, if you see such type of function where you have fx upon gx, try to cancel out the things if you are able to, then only. So from here, I can see that this x square, this fx, x square minus 1 can be written as x plus 1 x minus 1 by using a square minus b square identity. So x plus 1 x minus 1 over x minus 1, x minus 1 to x minus 1 cancelled, finally we got x plus, so in place of this we can write x plus 1. So now my question is such, x plus 1. Okay, this you can show definitely in the solution. Okay, now let's see its, this is our main, that means the value of x on the function. So if you are putting, no, here 1 will come, f1 is equal to 2, okay, f1 is equal to 2 on putting x equal to 1. Let's see is LHL. For LHL, we know limit x tends to 2 minus, 1 minus, because at 1 we are checking, no, this one, so 1 minus, and we are going to find its value on fx. So limit h tends to 0, in the very next step you can write limit h tends to 0, f, what it will be, 1 minus h. Okay, now put the value of function here. So limit h tends to 0, 1 minus h plus 1, which is 2 minus h. Put the value of h, 0, you got 2 as an answer. Keep it. Now here only I am making some changes and explaining you for the RHL. So for RHL, here it will be plus, here it will be what, plus, 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 and final answer will only be 2. So 2, 2 and 2, all the 3 values are same, hence it is continuous. Easy. Okay, so this will be the, let's see some more questions now. Okay, let's see this question. This is, I guess, question number 4th. This is the question number 4th in the book. Question says fx is equal to x if x is less than or equal to 1, and fx will give you 5 if you are taking x greater than 1. Okay, so now this is a inequality question. Previously we did not equal, that means x not equal to so and x is equal to so. Now this is another type of question. As I told you, there are just 2 or 3 types. Now this is some other type of questions. Now you have 3 sub questions in it, that for this function, is it continuous at x is equal to 0, is it continuous at x is equal to 1, or is it continuous at x is equal to 2? We have to check. So how we will start, what will be our approach? For this one we will have a particular algorithm. Okay, now for x is equal to 0 we will be checking its LHL, RHL and its value on the function. So if I say that let's check the value on its function, so x is equal to 0, x is equal to 0 means which condition I have to take? This condition says x greater than 1. Greater than 1 means 2, 3, 4, 5, 6, and this says less than or equal to 1. That means in this we'll get x is equal to 0. So for x is equal to 0 we are getting x as the answer. So at f0 we are getting x, but as we considered x is equal to 0, so finally our answer f0 is 0 only. So at function at x is equal to 0 we are getting x as the answer, because in this inequality satisfying x is equal to 0, so this will be our answer. But as x is equal to 0, so 0 will be, so f0 is 0. Now for LHL I told you we have to go for, so I'm directly okay, let me just write 0 minus, because for 0 we are checking. Okay, so it will be what, x, or directly you put the values, finally you will get 0 as the answer. Okay. For RHL, if you see limit x tends to 0 plus, okay, again you will get, because for 0 plus also we'll take this condition only, okay, and final answer will be 0. So all these 3 are zeros. So finally we'll say at x is equal to 0 this function is continuous. Okay, I hope this is clear. Now for x is equal to 1, let's check. So for x is equal to 1, this is the case because f is less than or equal to 1, so this will be our, definitely this will be the case. So f1 will be our answer, we got x, but x is equal to 1, so we get f1 is equal to 1. Now for LHL, what will be the thing? LHL, it will be limit x tends to 1 plus, and here again x, so what we will get? 1 plus, right? So it will be, no, 1 minus. For LHL we are checking, no? So it will be 1 minus, and if you put for 1 minus less than case, so you will get what? 1 as the answer, because 1 minus h, on putting h tends to 0 will get 1. So I am directly writing 1 here. Now for RHL, see, just have a look for RHL. Limit x tends to 1 plus of fx. Okay, here also fx is there, you can understand. Okay, I'm directly writing limit x tends to limit h tends to 0. Now what I will take, 1 plus means we are going in right hand side, so it is greater than 1, because 1 plus h will be the case. But for this we already have the answer with us, because when whenever you take x greater than 1, we will get 5 as an answer. So no need of considering any h, you can directly write 5 as the answer, because we are going in 1 plus. So it is more than 1, so we already have 5, so 5. So can you see this 3? As these 3 are not equal, so it is discontinuous. I hope the things are getting clear to you. Now let's check for x is equal to 2. For x is equal to 2, okay, what we are getting? If I put f of 2, so x is equal to 2 means x greater than 1. So for this inequality, this value satisfying. So the answer will be F2 is equal to 5. Okay. Now for LHL, okay, for LHL again we have to check for what? 2 plus and 2 minus. So for 2 plus you will get 5, for 2 minus also you will get 5. Okay, so all this values will be same and it will be equal. I have given you the hint. Now it's your duty to write it very properly. Okay, so write it and you can show me. Okay. Alright, so that's it for the today's lecture. In the lecture, we have seen some very important questions and important concept. In the next lecture, I will be continuing with the same exercise and some more questions, because we have seen two types, not equal one and this inequality one. One more type, that is in which we will be finding the value of k, given provided we will be having the function to be continuous at whatever value. Okay, so that would be our third type. So I request you to do questions up to 7th, okay, and see the example starting 7-8 examples. Do all these things in your fair copy, okay, and write all the definitions and whatever we have seen in the starting, okay. And in the next lecture we will be continuing with the same, and we'll do some questions on finding the value of k. And if any doubt, you are most welcome. Okay, take this chapter very seriously and thoroughly, because this is very important. 40% of your course is on the calculus only. I hope this will matter to you. So from the very beginning you have to show your utter seriousness. Okay, I hope you will understand and do the practice. Okay, thank you so much. Have a nice day. Bye bye.